Hey everyone, I'm Rowan Zellers and I'm presenting MERLOT Reserve, Neural Script Knowledge through Vision and Language and Sound. In this work, we've trained a powerful model that can watch a video and process all of these modalities together in a fused way.
Shut up.
I want to start with an example.
You were great tonight, really.
So there's a lot going on in the scene, but there are things we can infer from the audio, like that these people are being really noisy and rude. Yet even without sound, you might be able to look at this guy's body language and imagine the sound he's making. But there's something important here that goes beyond sound alone. It's an idea from developmental psychology and neuroscience called multimodal reentry. And the idea is that when we're exploring the world, we experience the same event through different senses and modalities, like language and vision and sound. And our knowledge gained from each modality supervises the other ones. And so in this work, we're going to learn fused video representations through multimodal reentry. Now, to contextualize things, I want to briefly talk about our previous work called MERLOT from NeurIPS 2021. The goal of MERLOT was to learn temporal script knowledge representations that cover language and vision. MERLOT learned this from YouTube without any human supervision. So the way that worked, given a video with subtitles, we split it into segments in time. And we used a single image frame from each segment of the video, along with YouTube's automatically generated subtitles. We're going to learn a frame encoder that represents each frame, tokenize the text, and then finally fuse everything together with a vision language temporal encoder. So MERLOT fused the video across modalities and over time, and we introduced objectives to train all of these components together end to end. But in this work, MERLOT Reserve, we want to jointly reason over everything, including audio. It's an exciting idea, but learning this trimodal fusion is even more challenging. Because we want to learn a fused representation between modalities, but now it's harder to get the supervision you need for pre-training. We could try to predict masked out words, but how do we mask out audio, which is this long-range perceptual signal? Moreover, as humans, we abstract away from little atomic sounds. We make more semantic and high-level predictions, which supervise our learning. And so in this work, we propose a general way to learn this. We'll take as input the whole video through all its modalities, but we'll replace an entire sequence of both text and audio with a special mask. And so the network at this position is going to need to anticipate not just the text that was said, but also the audio. We propose to learn this through reentry, using a new contrastive learning objective. MERLOT Reserve will predict the vector about what we think the audio might be. And we'll likewise encode the audio of this sequence in isolation to get a single target vector. We're going to learn the model by maximizing this contrastive objective. And we'll do the same thing for spans of text, learning representations that go beyond single words. And that's MERLOT Reserve. Using these objectives, we train it at scale over 20 million YouTube videos covering diverse topics. Now, to evaluate MERLOT Reserve, we'll first use the VCR benchmark. It consists of images like this one, as well as challenging questions, like why is the man pointing? On VCR, MERLOT Reserve gets 71.5%, even better than MERLOT, as well as past supervised models, thereby suggesting that multimodal reentry leads to stronger vision and language representations, even for a task without sound. MERLOT Reserve does even better, though, for benchmarks with sound. It gets state-of-the-art performance on TVQA and kinetics. Now, even better, MERLOT Reserve is capable of zero-shot video QA. I've got a demo here that you're welcome to check out. We can give it the diner scene and tell it to predict what's more likely. Is the man pointing because he wants to tell the server who ordered the pancakes, or to accuse the other man of something? Here it says the man is pointing because he wants to tell the server who ordered the pancakes with 90.3% probability. And again, this is just done in a zero-shot setting without fine-tuning on VCR data. And so that was MERLOT Reserve, a pre-trained model for trimodal neural script knowledge. Feel free to check out more information on our website at rowanzellers.com/MERLOT Reserve. And a shameless plug, Ximing is applying for PhD programs this fall.